Hello my dear students, this is P. Venkateshwarlu, PGT Physics. In previous video, we have to start that new chapter, chapter 10, Mechanical Properties of Fluids. Okay, and we discussed pressure, thrust and last density. Okay, in this case in this video we have to discuss about Pascal's law. Pascal's law. Pascal's law. See here, what is Pascal's law, my children? Yes, pressure in a static fluid is equal at all points which are in same height. One more time, my children. Pressure in a static fluid at all points equal which are in same height. Pressure in a static fluid is same at all points which are in same height. Okay. See here. So for this proof, we can consider one vessel. We can consider one vessel like this. Okay. So in that we have to take one object like this. Okay. See here. Here we can denote a force applied on the object A. Here force applied on the object B. Here force applied on the object C. Okay. Understand? See here, one thing you know, my dear children. When here in liquid pressure always acting normally to the surface. Okay. So this is surface, pressure acting like this. This is the surface, pressure acting normally. Here surface is there, for that opposite pressure is acting. Okay. See here, pressure means force per unit area. So if we can apply force, then we can get the pressure. Okay. Understand? See here, this is A, B, C, D, E. Okay, understand? So here area is A small a. Here area is A small c. Here area is A small b. Okay, understand? Here FB. See here. So we can represent FC and FA, means pressure A and pressure B, which is acting normally. Okay. See here in this here at point B, force acting normally, but it is not x-axis and it is not in y-axis. Then consider this force vector B. Okay, like this. Okay, we have to displace like this. Okay, we can draw a perpendicular line. Here making angle theta. Okay, understand? Now here we can get FB cos theta. Here FB sin theta. Understand? So my dear children, this is x-axis, this is y-axis. But FB is which axis we don't know. Okay, that's why according to vectors, force vector can be resolved into the x-axis and y-axis. So that's why the force vector acting downward F cos theta, the force vector horizontally FB sin theta. So like this. Okay, which is FB sin theta. Okay, in this way we can get what, my children? FB cos theta. Okay, understand? FB cos theta. So in this case, if the system is equilibrium, so this entire body is immersed in water or liquid. Okay, in this case, three different types of forces acting because three surfaces is there. Okay, so this is x, this is y, this is x. Here we don't know. By resolving FB, we can get FB cos theta downward. FB cos theta downward and FB sin theta horizontal. So by using this we can say that is what might children? FC by FA is equal to what might children? FB cos theta. FB cos theta. Then area small a is equal to what might children? Yes, AB cos theta. At the same time, area vector also can resolve. Okay, understand? Now we can give area B here, AB cos theta, AB sin theta, based on this. Okay, AB cos theta. Understand? 1, 2, 1, 2. So FA by AA is equal to FB cos theta divided by AB cos theta. Cos theta gets cancelled. FA by AA is equal to FB by AB. Okay, understand? This is equation 3. This is equation 3. And whenever horizontal, okay, FC is equal to FB sin theta. Okay, FC is equal to FB sin theta. Okay, it is equation 4. Then AC is equal to AB sin theta. 4 and 5. FC by AC is equal to FB by AB sin theta, sin theta. Sin theta gets cancelled. We can say FC by AC is equal to FB by AB. Okay, understand? So this is equation 6. Equation 6. Understand, my children? Understand? So once again I will explain. No need to worry. Okay, equation 6 and 3. Equation 6 and 3. Equation 6 and 3. FA by AA is equal to FB by AB, FC by AC. Okay, what is force per unit area? Pressure. Pressure A is equal to pressure B is equal to pressure C. Understand? So according to this what Nana? Pressure at A is equal to pressure at B is equal to pressure at C. Pressure at C. Understand, my children? Okay, according to this, pressure in a static fluid. Pressure in a static fluid is same at all points which are in same height. Which are in same height. Understand, my children? Understand? Understand, my children? Yes. Okay, my children, one more time I will explain about diagram. Okay, consider a vessel. Okay, so in the vessel fluid is there. Okay, fluid means what, my children? The substance which can flow. Yes, what is fluid? The substance which can flow. So examples of fluids, yes, liquids and gases. So here we can take one fluid. It's may water, it's may gas. So we can immerse one object, okay, which look like a right angle. Okay, see here, this is A, this is B, this is C, D, E. Okay, so this is A surface. Okay, this is A, this is B, this is C. Okay, so in this case we know that according to thrust. Okay, thrust means which is a force is normally acting to the surface. Means whenever object is immersed in any fluid, the fluid force which is acting normally like this. Here F FA. Okay, FA. And here, what is the area here? A. Understand? Now here, the force is acting, or the thrust is acting FB. What is the area here? AB. Okay, here which force? FC force is acting. Here what is the area? AC. Understand? Here, by observing this A and C, which acting y-axis, which acting x-axis. Okay, here consider B, which is not in x and y, So that's why we can resolve that force vector x and y. Understand, my children? X and y. This force vector can resolve. Resolved in x and y. Okay, based on the component of vector. This force vector we can act, which is in this way. This is force. Okay, so we can draw the x and y axis. Here making angle theta. Okay, so based on that, this is FB. Here we can get FB cos theta. Here we can get FB sin theta. Understand? So now the force vector acting opposite to the FC is FB sin theta. Understand? So then area vector also we can get AB is equal to AB means AB sin theta. Understand? In this way, area becomes AB sin theta. Force becomes FB sin theta. Understand? In this way, along y-axis, we can get FB cos theta. What is area? AB cos theta. Understand? At the equilibrium position, the sum of the upward force is same. Okay, understand? That's why we can equate both. Understand? X-axis and y-axis, and we can get final expression. Okay, F A by AA is equal to FB cos theta divided by AB cos theta is equal to what, my children? FC by AC. Then equal FA by AA is equal to FB by AB is equal to FC by AC. Okay, understand? Force per area. Force acting per unit area is called pressure. Pressure at A is equal to pressure at B is equal to pressure at C. Okay, my children? According to this, what, my children? Pressure acting in a static fluid. Is same at all points which are in same height. Okay, so at this point, pressure acting due to the fluid is same, my children. Understand, my children? Yes, remember it. You can observe. You can go through reference books. You can get the knowledge. Understand, my children? Okay, next we can get variation of pressure with the depth. Variation of pressure with depth. Variation of pressure with depth. Okay. So in this case, if the depth of the liquid increases, what happens? Okay, pressure will changes or not. So we have to find, okay, by using derivation. So consider a vessel. Consider a vessel. In this vessel we have to take some fluid. Fluids means it's a water or any gas. So in this purpose we have to take water. Okay. So water is available free of cost. Okay. Understand? So now we can consider one cylinder, one object. Okay. Like this we have to take. Okay. So the length we can say h. Length we can say h minus length h. This area of cross section is A. Here also area of cross section A. Understand? We know that when an object immersed in fluid, some thrust is acting. So thrust means always acting perpendicular to the surface. Now here force is acting. We can say that is denoted Fa. Okay, Fa or F1. So force is acting in this way. Here one area is there. Then here also force acting. That force is called F2. Understand my children? Okay, in this way, sideway pressure also is there. Pressure acting upward, downward, and sideway pressure. Okay, understand? So here, according to this pressure at the same point, which are all in same height is same. So in this way pressure acting. So both side pressure gets cancelled. Okay. So then here some mass is there. So due to mass, weight acting downward. Understand? Close it. Okay. So this body having mass. Okay. So due to the mass, weight acting downward. Okay. Understand? So this is the diagram. Okay. Very important. Consider a fluid, consider object, height is h, thrust is acting downward and upward. Okay, area of cross section A and A, uniform area. Okay, so in this case we can write the free body diagram. Okay, so free body diagram, very important. Free body diagram is a diagram, okay, which represent all forces acting on the body. Okay, consider this object like a point object. Okay, in this object, which forces are acting? F1 force acting in which direction? Okay, downward direction. Okay, then F2 force acting upward. Okay, so then weight also it is a force. Which is acting downward. Understand? In this way, weight also acting. In this way, weight also acting. Understand? At equilibrium means the sum of the downward and the sum of the upward force is same. Okay, understand? So here, one force is acting upward, one force is acting downward due to the liquid pressure. Okay, due to the thrust. Whenever an object immersed in water, some force is acting on the body. Okay, understand? That force we can denote as F2 and F1. Here some force is acting, here some force is acting. Here also acting, but both are in opposite. They get cancelled. Okay, so here consider this object in like a point object. Okay, so F1 force acting downward, at the same time weight vector also acting downward. Then F2 vector acting upward. Okay, at the equilibrium position, F2 is equal to the sum of the upward force. F2 is equal to F1 plus mg. Understand? Then F2 minus F1 is equal to mg. Okay, here what is F2? What is pressure? Pressure is equal to force per unit area. Then force is equal to pressure into area. Okay. So now we have to write like this. F2 is equal to P2 into A. A is constant. P2A minus. Then F1 is equal to P1A. P1A is equal to mg. Okay. Here what is m? From the density is equal to mass per unit volume. Okay. So then mass is equal to density into volume. Then volume is equal to density into area into height. Okay. Remember, my dear children. Okay. Understand, it is visible. Mass is equal to density into volume. Volume is equal to area into height. Area into height. Okay. Then P2 minus P2 minus P1 into A is equal to, so we have to write instead of mass, rho into A into H into G. Okay, rho into A into H into G. A gets cancelled. P2 minus P1 is equal to rho G H. Okay, understand? P2 minus P1 is equal to rho G H, my dear children. Understand? Okay, here variation of pressure with density. Variation of pressure with density is equal to rho GH. Rho GH, my children. Understand? So then, rearrange this. Pressure at this point P2 is equal to P1 plus rho GH. Okay. Pressure at depth. Pressure at depth is equal to pressure at a point A and pressure due to height. Okay, here in this case the pressure in a static fluid it depends upon the height of the liquid column. My children. Understand? So in this case, pressure is directly proportional to density. Pressure is directly proportional to height of the object. The variation of pressure is directly proportional to density. The variation of pressure is directly proportional to height of the object. Understand, my children? Okay. So what is variation of pressure with depth? Okay. Understand? So this is the derivation. See one more time. Okay. You can understand easily. Yes, my children.